Okay, just when you thought you were rid of me, I came up with another way to justify why two negatives multiplied together become a positive. And I'm going to use tiles. I've got red ones and yellow ones. The yellow ones are represent positive integers. The red ones represent negative integers. And I don't know if you can see these little problems here because they're kind of small. I'm getting old, so I can't see them as well. Good thing I have my glasses on. But let's just talk a little bit about what each one of them means. I'm just going to move my negatives down here, keep them where I need them to be. Okay, so let's start off with a basic one, 2 times 3. What does 2 times 3 mean? In chip land, it means put on two groups of 3 positive integers. Because this is positive, the first number always is going to represent what we're either putting onto the table or taking off the table. Okay, and then the second number is going to be what we're putting on or taking off the table. So this one says put on two groups of 3 positives, because this is positive and that's positive. So put on two groups of 3 positives. Okay, so it's a little slower than I thought. There's one group of 3 positives. And here is a second group of 3 positives. So I'm putting on two groups of 3 positives. What do I get? Looks like I get 1, 2, 3, 4, 5, 6. I get 6. 6 positives or positive 6. Okay, that's kind of the game for the rules for the game. First number tells, if it's positive, it tells us we're going to put on chips onto the screen or onto the table. And if it's negative, it says we're going to take off chips. Okay, so 2 times 3 gives us positive 6 because we put on two groups of 3 positives right there. Okay, that was awesome. Now let's move these over here. Well, I probably could leave them there. I don't know. I haven't really practiced this video. This is a rough draft video, and fortunately it's not going viral. Unfortunately, my life doesn't depend on how well my YouTube channel is going, because it's not going, because I don't care. All right, so the second problem here, 2 times negative 3. This says put on two groups of 3 negatives. Okay, well, here's my negatives. I'm going to put on two groups of them. So 2 groups of 3 negatives. Okay, there's 1, 2, 3, 4, 5, 6. Okay, so I put on two groups of 3 negatives. 1, 2, 3, 4, 5, 6. There's 6 negatives in total. That must mean that 2 times negative 3 is negative 6. And that's all based on multiplication. I put on two groups because they're positive, and two groups because there's 2, and then negative 3, that's what I was putting on, two groups of 3 negatives. 1, 2, 3, 1, 2, 3, I get negative 6. Okay, so now we know that 2 times negative 3 gives me negative 6, which leads me to think that maybe if the signs are different when I multiply them, they become negative. But we need to look at this negative 2 times 3 because we're not going to rely on the commutative property like we did in the last video, which you may or may not have seen. We're gonna attack this one too, because when we attack this one, it'll prepare us for the negative 2 times negative 3. So move these chips over here. Okay, so we got all our chips. Now, so right now we are working with a blank slate. And let's look at the problem. Sorry, I'm just feeling organized or something. Who knows? I'm usually not organized. It must be the summer thing. So we're going to look at negative 2 times negative 3. It says take off two groups of 3 positives. Okay, I don't have 3 positives on my board yet. That's a problem because then I can't take them off my board. So we need to figure out a way to get positives on there, but we don't want to change the value of the board. And right now the board is 0 because there's nothing on there. Nothing on there. And so what can I put on? Let's see. If I put one positive on there, I've changed the value of what's on the board to 1. But I want it to be 0. So I know that I can add -1 to +1, and I get 0. So right now my net, my total on my playing board is 0. Okay. So I'm gonna put quite a few of these on here. Oops, that's not what I want. Put that there. Let's put this one here. Okay, let's check. Let's check halfway through. I still have 0. Let's do some more just for funsies. It'll be grand. All right, so there's, and we have -3 on the board right now, but we still want it to be 0 because we haven't started multiplying yet. We don't want to change the playing field. We don't want to change the board. We still want to start with 0. Over here we started with 0 and then put on 2 groups of 3. Over here we started with 0 and we put on 2 groups of -3. So over here we're starting our playing board with 0, right? Because each one of these, what I want to call 0 pairs, adds to be 0. -1 and +1. -1 and +1. They all add to be 0. So far I don't have any, haven't changed the value of my playing board yet. It is still 0. Now it says take off 2 groups of 3 positives. Okay, well I'm going to take off 1 group of 3 positives. There's 1 group. And I'm going to take off 2 groups of 3 positives. And okay, so I took off, there's that 1 group of 3 positives. There's the second group of 3 positives. I took them both off. What is left? 1, 2, 3, 4, 5, 6. 6 negatives. So -2 times 3 is equal to -6. Now that's amazing. These are the same, but I did a different process. Over here I took off 2 groups of 3, but I could do that because I had what we called a 0 pair. I think I might put a 0 pair over here just to remind you. This is a 0 pair because -1 plus +1 gives us 0. Okay, so now we're set up to do -2 times -3. I think I'm gonna move these over. I'm gonna move these over. Maybe just because I'm a teacher, I like to do things a little different. I'm gonna do something kind of fun because this is what students might do. Now you're gonna have students who already see what's going on, but you know, when this would a question I might ask students is, does it matter how many 0 pairs that I add to our board or to our playing field? Does it matter how many we add? I'm hoping that they would see that it doesn't matter how many we add. In fact, we could add all the chips we have. Just as long as we're starting off our playing board with 0, we're okay. So I've added them all. Does not matter. Now some of your smarter kids will be like, you don't need to add that many. Doesn't matter. It's good that they see that, but the point is that I can put on as many as I want. Okay, sorry. I had to do a little teacher moment. So now I've got -2 times -3. Now what does this mean? This means take off 2 groups of 3 negatives. So notice I'm starting with 0. Okay, I need to take off 2 groups of 3 negatives. Okay, so I'm going to take off 3 negatives up from up here. 1, 2, 3. There's 1 group of 3 negatives. Let me take off another group of 3 negatives. 1, 2, 3. Okay, here's my 2 groups of 3 negatives. Let's see what's left over. Okay, now notice this bit here. This is all 0. This is all 0, so we're not going to count that. We're only going to count the chips that don't have a partner. 1, 2, 3, 4, 5, 6. 6 positives. Huh. Who knew? So -2 times -3 is a +6 because that's what's left over after we took off our two groups of 3 negatives. Is that a proof? Not sure, but I feel like it's a little bit more of a, it helps convince that this is the reason it is. It helps us convince students about the rule without having to say, that is just because I said so. We don't need to be that kind of teacher. Okay. All right. Well, that was fun. Maybe I'll use this to try this again and make it more better. Hee hee.